and the IL are set up to 1, and then the KD varies from 4. So this is 0.4, this is 0.56, this is 0.7, 0.85, and this is 1. And you'll notice that there's a slight amount of kind of illumination, brightness, that is coming onto the top of the ball. But the IA and the IL are both as bright as they possibly can be. They're 1. If in this one you kind of ratchet it back, what did they do? Oh, I just got those backwards. This one is where it's just they don't have any ambient light. They just have this one, and all they're doing is lighting it with the diffuse part. That's why you're getting this effect. This one has ambient light, so I just got those flipped around. The ambient light and the light source are both set to 1, and then basically they are changing the KD. And you get little kind of shining on it. Okay. The last intensity model adds into it what is called specular reflection, and it's this ILKS cosine to the nth power of alpha. And basically you can see that it's again a specular reflectance coefficient. The alpha is the angle between the eye and the reflectance vector, and n is kind of a shining factor. And if you look at kind of this set of spheres that have been lit, you'll notice that here down at the bottom, the n is all the way up to 200. So with it being 200, you get a very small, very focused dot that is reflecting, that is shining. So the angle between the eye and that is really very tight, very focused. And you can just see the difference that's done by setting those different values. This set of slides has been uploaded to TCC. I would encourage you, we're going to run out of time here really quick, I would encourage you to go and look at the mathematics, because what we're doing is basically saying if you're giving an illumination vector, you're given a normal, you're given basically a vector for your eye, you're given a bunch of KAs and K and IA values. If you're given all of those, you should be able to kind of compute this, but you have one kind of problem. The problem is, where is that reflectance vector? And because it's a 3D vector, you need to be able to figure out where the reflectance vector is, and knowing that, be able to calculate what the angle is between the eye and the reflectance vector. And this just basically steps you down through figuring out that calculation. What we want to get to is this discussion. So in lighting a scene, what is the computer actually doing? Well, the computer is figuring out a point on a surface. So what is P here? Well, P is actually some P of U and V, or S and T. You've got some Bezier surface, and you've fired a ray through your screen, and you've hit a point on the surface. Once you've hit that point on the surface, can you figure out its location? Its X value, its Y value, its Z value? Can you figure out its normal? You can through the Bezier formulas that we've talked about. Knowing the point P, you can calculate a normal. If you're given where the light source is and you're given where the eye is, can you figure out the other stuff? You can, but the question is, what is the computer doing to render that image? Well, it's figuring that out at that location, and then it's stepping just slightly left because it's fired another ray, and so it's hitting the screen at a slightly different location, and it's rerunning the formula all over again. And it's moving over and it's firing another point because it's going through and firing rays through every pixel. So if you ever see the CAD system paint the image down or paint the image up, it's literally firing these rays and just slowly painting up the image based on this calculation. Does that make sense? How does it get the H and the S? This is just I. How does it get the H and the I? Where did they come from? Is that a math equation?
We set the I.
You don't set the I, you calculate the I. Okay? Calculate the I. You set the H and the S. You decide how bright the color is, right? I want this to be a real green surface, okay? Or you set the color of the light. You can also specify that the light is green, or the light is red, or the light is... And it becomes...
Does it mix the colors of the surface and the light?
So, is this paint? No, it's not paint. It's light. So what happens when you add more and more colors of paint? What do you get?
Mud.
You get mud, eventually black. In light, what do? If you're adding more and more different colors of light, you eventually get it to
White.
White. Okay. And so you choose the H, you choose the S. The computer calculates the intensity for every point. Question.
So in renderings, is I always white light, or can we set the hue of the light source as well?
You can set the hue of the light source. So as you're defining lights in the CAD system, there will be a spot where you can say, I want this to be a blue light. I want this to be a yellow. I want this to be a green light. So you can do that. So I would challenge each of you to begin looking at someone on your team taking a dive into rendering. If you have somebody that's into photography, that would be a good person to kind of go in there and figure out the rendering so that that person can kind of share their knowledge with everybody on the team.
The TAs rendering like experts or
Rendering experts?
yeah.
So Eric and Jared are both pretty good.
Yeah.